Here you go. Section 4.3, day 1, polar coordinates. This is going to be new for you guys. Brand new. So let's dive in. Pre-lesson. 4.3, day 1. So here we go, you guys. Just warming you up. You all are very, very familiar with your good old x-axis and your y-axis. And we call those rectangular coordinates. So in the craziness of this next couple of days, don't lose sight. Rectangular coordinates are just what you've been doing for your whole life. I mean, back to elementary school. So if I said, hey, what is this? You know, I want to know what that point is, that rectangular coordinate point is. You go, hey, that's a 45, 45, 90, and this is 2 square root of 2. Remember, if we had something like this, x, we'd multiply by the square root of 2. So how do we get back? Well, you divide by the square root of 2. Hopefully that's not too confusing to you, but this is 2 and that's 2. So my rectangular coordinates would be, there's my x, and there's my y, and you're like, hey, I think I get this. Well, you should. So this is just 2, 2. But we are going to identify the same point using what's called polar coordinates. Now, what does R stand for? Well, as you can see, we're going to be dealing with circles. Hint, hint, nudge, nudge. So what do you think R is? R is the radius. Now, I've been referring to it as the spinner. The spinner turns into the hypotenuse. But it's also the radius, because if a spinner is going around and around, what's it making? It's making a circle. We haven't been drawing it every time, but then we're drawing our triangular, our right triangle so that we can use our trig there. So, what is this? That's how far in degrees or radians we spin what I've been referring to as our spinner. Now remember, our spinner, which by the way, remember we've been using vectors, so now we can say vector. So we've got vector, spinner, radius. What else? Anyways, we'll stop right there. How far you spin your spinner? In degrees or radians. Well, wouldn't that be right here? So it's 45 degrees. So my rectangular coordinate would start with the length of the hypotenuse, spinner, vector, and then that would be 2 square root of 2. And then how far do we spin our spinner? We spun it 45 degrees. Now, a lot of times you will see this in radians. Don't panic. Don't panic. Now, what's this here for? I'll explain this in a second, but I got to go through this. This is a very unique, very, very strange moment that happens in polar coordinates. Now, I don't know if you've ever heard the phrase, boy, me and him, boy, we're just polar opposites. Or me and her, polar opposites. This is where it comes from, okay? So what do you do if this is a negative? Well, the first thing you do is you ignore it. I say, save it for last. Don't forget it. So what we're simply trying to do is simply just plot the point, -3 comma 2 pi over 3. Well, so if you ignore it and save it for last, your mind, I'm encouraging you to just think about that. So what does that help us do? Well, it helps us understand that our radius is 3, and it helps us understand, whoops, don't know why I did that. That's going to be 2 pi over 3, which, by the way, what's pi over 3? 60. What's 60 times 2? 120. So I have uniquely got that ready for you. So my spinner is 3 units long. You see, that's what this bullseye sort of thing. It's like an archery target. So there's the length of our spinner, our radius, our vector. But it's saying, hey, spin it 120 and stop. So it's like, zzz. So we're not going to be perfect about this, but there it is. Okay, now listen very carefully. If this is what we were plotting, we would say, there it is, right there. That's the point we were trying to find. If it was like this, Problem is, it wasn't. You got to think a little common sense here. Does this really mean you have a radius with a negative length? That's impossible. So it must mean something else, and it does. It means polar opposites. Couldn't be from farther ends of the world, sort of thing, okay? Which means the last thing you have to do is honor this. And that negative means you need to go completely opposite right along this. Think of it as the circle's diameter. See this circle right here with radius 3? And you go right over here, and that is the final answer, believe it or not, for negative 3, 2 pi over 3. Now this little concept's going to mess with you a little bit, but you'll get used to it.